Good morning, members. That's the time when we're looking at linear motion. We exactly stopped on retardation, which we defined very well and said this is the negative rate of change of velocity with the time. And mathematically, we treated it well and said deceleration, or simply retardation, is equal to negative into v minus u divided by t, where v is the final velocity of the object, u is the initial velocity, and t is the time taken for the change of velocity. And we also looked at an example where we said that a body moving at a velocity of 10 meters per second is brought to rest after 5 seconds, and we asked to find the acceleration of the body as well as its retardation. In our solution, we said acceleration is equivalent to v minus u divided by time. That is its mathematical treatment, where the initial velocity u is equal to 10 meters per second, because we did mention that that's the velocity with which the body starts its motion. In other words, according to the observer, you started observing the body when it was moving at 10 meters per second. The final velocity, since the body is brought to rest, it becomes 0 meters per second, and the time taken is 5 seconds. In our substitution, we therefore have a is equal to 0 minus 10 divided by 5. And eventually, this did give us a is equal to negative 10 divided by 5. And that rests our answer to 2 meters per second squared. That is a negative value, by the way. It's negative because the velocity of the body decreased from 10 meters per second to 0. Then retardation, being the negative rate of change of velocity with the time, it becomes negative into v minus u divided by t. And this means our retardation is minus into 0 minus 10 divided by 5. That is negative into negative 10 over 5. And it is equal to negative into negative 2, which becomes a positive 2 meters per second squared. By the way, the negative has disappeared because a negative times a negative becomes a positive. Some of us may not easily see that, but you look at this. If we say our retardation is equal to minus into minus 2, it means you have minus 1 outside, which is hidden, times minus 2, and that exactly gives you positive 2 meters per second squared. So that's how we determine our retardation. By the way, realize that from the expression where we calculated the acceleration and said is negative 2, our retardation would simply mean retardation is equivalent to negative of the acceleration we have calculated. That is exactly negative into negative 2, and eventually this gives you a positive 2 meters per second squared. So you really have to understand that retardation is the negative of acceleration. We left when we had promised ourselves that when we come back, we are going to look at how we convert units of velocity, or simply units of speed. Because sometimes we give you the speed in different units, and we require you to utilize that speed in a particular unit, or maybe in its SI unit. So let us look at unit conversion briefly before we head to another part of linear motion. We have converting units of velocity. Units of velocity, converting units of velocity. You could be given this. Let's look at an example on how we can convert the unit of velocity. Example. Convert the following units. Convert the following. Convert the following. Convert the following. Convert the following to the required units. To the required unit. To the required unit. By the way, we always give these examples, but sometimes it is important for you, before you go to the solution, you pause the video and you try out the example yourself before you go ahead to look at what the teacher has given you as a solution in this video here. So always do pause, try it out yourself before you head to the solution. And the question is, part A, we need to convert 108 kilometers per hour to meters per second. And then in another part, possibly part B, we need to convert 60 meters per second to kilometers per hour. So in our solution, how do we do that? How do we convert kilometers per second, per hour to meters per second? It is that simple. You can simply say, if they look at 108 kilometers per hour, this is the same as you having 108 kilometers over 1 hour. Yes, you did indices. That term power, h power negative 1 means 1 out of h. And 1 out of h the same as 1 out of 1h. So that is 1 hour. But you realize, you know very well that 1 kilometer is equal to 1,000 meters. Recall, we are converting it to meters per second. So this would mean that 1,008 kilometers is equal to 108 times 1,000. And that gives us 180,000 meters. Also, we understand that 1 hour is equal to 60 minutes. 60 minutes. But remember, 1 minute is equal to 60 seconds. 60 seconds. So this would imply that 1 hour, which is equal to 60 minutes, is equivalent to 60 times 60 seconds. And this is equivalent to 3,600 seconds. Now, we solve this going backwards. This would mean that you have 108 kilometers per hour being equal to, what is the 108 kilometers in terms of meters? Is equal to 180,000 divided by 3,600. And when you use your calculator properly, you come to consensus with me that this gives you 30 meters per second. Remember, what is up is in meters and what is down is in seconds. So that gives you 30 meters per second. So that's how you could convert the speed given to you or velocity given to you in kilometers per hour into meters per second. So let me look at the second example where they want us to convert from meters per second to kilometers per hour. How do we do it? It's actually the reverse process. It's the reverse process. We have 60, that is part B, 60 meters per second is the same as 60 meters out of 1 second. So we need to put that in terms of hours. What do we have? We need to recall 1 meter is equal to 1 out of 1,000 kilometers. 1 meter is equal to 1 out of 1,000 kilometers, implying that 60 meters is equal to is equivalent to 60 out of 1,000 kilometers. We leave it in that format. Also, we can talk about the time, and we say 1 second is equal to 1 out of 3,600 hours. Now, this would mean that 60 meters per second, as we agreed, is equivalent to, where there is 60 meters, you put 60 out of 1,000. Now we divide it by 1 out of 3,600. So this would mean that 60 meters per second is equal to 60 out of 1,000 multiplied by the reciprocal of this one here, 1 out of 3,600. It becomes 3,600 divided by 1. Make some good multiplication there. What do you get when you make that multiplication? When you make that multiplication properly? When I make that multiplication properly, I think I come to this value, 216 kilometers per hour. 216 kilometers per hour. So that's how we convert the unit from meters per second to kilometers per hour. Now, let us have a simple example here again, like around 2, and we say, to remind ourselves how we calculate acceleration. Example here. My ink is getting done there. Let me try to change to another ink. Example, we are saying that number 1, a car starts from rest. And acquires a velocity of 60 meters per second in 30 seconds. Then they ask you to find the acceleration. Find the acceleration of the car. We can't ask you to find the deceleration here. The reason why we cannot ask you to find the deceleration, because the velocity is increasing, and we agree that when the velocity is increasing, then what we calculate in that case is acceleration, not deceleration. So our solution here, we have acceleration, which is denoted by letter small a, is equal to final velocity minus initial velocity divided by time. Now you need to put down what the final velocity is. Remember, the car starts from rest, and acquires a velocity of 60 meters per second. So final velocity is equal to 60 meters per second. Then initial velocity, since it starts from rest, this is u. Initial velocity is equal to 0 meters per second, and the time taken, they told us it is equal to 30 seconds. Now this would mean that our acceleration is equal to initial final velocity, which is 60 divided by initial velocity, which is 0, then divided by time, which is 30 seconds, and this is equivalent to 60 divided by 30, and therefore your acceleration A, when you use your calculator properly, it will give you something equivalent to this is, I think, 2 meters. Sorry for that, this thing is not writing properly for me. 2 meters per second squared. 2 meters per second squared. That is the acceleration of the car. Acceleration of the car. That is the acceleration of the car. So example number 2. Let's go to example number 2. Example number 2. Example number 2. This is how it goes. A body moving at a velocity, with a velocity, by the previous example was supposed to be with a velocity of 80 meters per second, changes to 60 meters per second in 2 seconds. Full stop. The question is, find the retardation or the deceleration. Find the deceleration of the body. Find the deceleration of the body. Now this time around it's deceleration because the velocity is decreasing. Remember, it's from 80 to 60 meters per second. So here in our solution, what we do, remember, deceleration is the reverse of acceleration. In other words, it's the negative acceleration. So we say deceleration is equal to minus into v minus u divided by time. I think you call that the initial velocity here. In this case, the initial velocity u is equivalent to 80 meters per second. It's always good to start with the initial, by the way. Then the final velocity is 60 meters per second, and then the time taken to change the velocity, we are told, is 2 seconds. So this means that deceleration for that matter is equal to negative into 60 minus 80 divided by 2, right? Divided by 2 seconds. What do you get here? This is the same as minus into minus of 20 divided by 2. I think 60 minus 80, you get negative 20. When you pull this, when you open the brackets, this negative outside will affect negative inside, and it will be like getting negative 1 times negative 20 out of 2, so it becomes positive 20 out of 2. So this is 20 out of 2, and eventually we get the answer as 10 meters per second squared. So that's how we get the deceleration of a body. Deceleration of a body. Now, that has reminded us on how we calculate the acceleration and the retardation. Remember, we have looked at several terms here. We've looked at velocity, speed, distance, displacement. Eventually we came to acceleration and retardation. Not forgetting, we also looked at uniform speed, uniform velocity, uniform acceleration. By the way, even uniform deceleration is also there, and that would be the constant negative rate of change of velocity with the time. In case you are asked to define it, you could give that as an answer. So all these terms can be put together. They can be put together using expressions. In other words, we can relate all the terms: acceleration, final velocity, initial velocity, the distance, or simply the displacement, using equations which we call equations of uniformly accelerated motion. Therefore, next time when we meet again, we are going to look at uniformly accelerated, equations of uniformly accelerated motion. Thank you for today. Bye bye. We meet next.